Hello, today we are doing problem 9.66, and this problem asks us to start with our starting material ethylene oxide, which is an epoxide, and treat it with the following reagents. So we have 6 different conditions, and let's start going through them. So in A, we have an epoxide, and we have a strong acid, HBr. So we know HBr dissociates to H plus and Br minus. So oxygen being electron rich and having nucleophilic tendencies, we know that that is going to be protonated and pick up one of those protons, forming oxygen with 3 bonds, which gives us a formal positive charge, which is not favorable, but we have a strong nucleophile to save the day. And because both of these carbons are equivalent, they have same steric hindrance at each site because they both have 2 protons. We know that it doesn't really matter which side bromine or any of these following reagents will attack because they will yield the same product. So we will arbitrarily choose one of the sides, and we'll go through SN2 epoxide ring opening, nucleophile attacks, making a new sigma bond, and then we have to break a bond so the epoxide pops open to generate our alcohol. Next, we have water in strong acid. I like redrawing my strong acids to HA. You guys know that. And same thing again. We'll protonate our epoxide using that strong acid to generate our intermediate. But now water is going to act as our nucleophile and attack one of these sides. But now we need to deprotonate this water, and what we can use to deprotonate it is the A minus, the conjugate acid of this. So what we can do is, using that A minus, pick up that proton, make a new bond. When you make a bond, you break a bond. So those 2 electrons on that sigma bond goes onto the oxygen nucleus, forming our product and reforming our acid catalyst. So next, for the third example, we are starting first with a nucleophile, then we're hydrating everything. So if I were to use this nucleophile, I know that is going to attack one of these carbons to pop open my epoxide. You make a bond, you need to break a bond. But now we have a negatively charged oxygen, but we are adding hydrogen, we're adding water to the mixture. So we know in step 2, this oxygen being very negatively charged and very electron rich can easily pick up one of those protons from water to form the same product as in B. Plus OH minus. Next, we have an alkyne, but if we have on one of the carbons, we have a carb anion, so it's a highly nucleophilic substance. And we know that it's going to attack one of those electrophilic carbons, popping open our epoxide in the first step. And obviously we add water to neutralize everything. In the second step, so then we get our neutralized product with hydroxide ion. Next, we start with the hydroxide and then we add water. So we know hydroxide would act as a nucleophile, attacking that electrophilic carbon, popping open our epoxide, and hydrogen and water, in the second step, will neutralize everything just like in the previous examples. Next, we start with a thiolate. So thiolate is you can imagine sulfur and oxygen having very similar trends and properties. So a thiolate is just like negatively charged oxygen. So arbitrarily it attacks one of those electrophilic carbons, popping open our epoxide. Water protonates everything and neutralizes everything. So now we have our epoxide ring open product plus our hydroxide.